our next speaker, Mr. David King, who is the founder and CEO of Exactive. And Exactive is a company that specializes in producing data visualization tools to facilitate the cross-fertilization of ideas and innovation. And it created our web-based integrative medicine map that you just saw. If a picture is worth 1,000 words, then I think an interactive map is worth 1,000 pictures. And so I will let David take it away. Thank you.
Well, thanks for having me, and it was great to get all of these great examples from Dr. Barabazi, where we saw networks that were comprised of so many different things. We saw networks that were comprised of people, networks that were comprised of atoms, networks that were comprised of genes. And once we get my slides up, I'll tell you about the sorts of networks that I'm particularly interested in. Harvard Conference. Yep, that's it. At one point, when Dr. Barabazi was talking, he said, okay, so this is how networks behave, so what? So what then, right? And it's showing up here, but not there. And I think that's a really important question. That's the question I kind of want to use my talk to pull us back to. We understand these amazing phenomena. We see the math behind the networks. We see how they behave. And we're even now aware that we're all part of one of the integrated medicine community. So what? What does that mean for us? And it's funny, it's just after Halloween. It's kind of a Halloween title. There are people in the dots. This is what I get really excited about, is that while there's networks for all sorts of different things, and almost all the times when you see these sorts of network talks, you see a lot of dots and arrows. And we even talk about, in our lexicon, we talk about connecting the dots. But one of the things I want to spend today talking about is that there are people in those dots and what happens when you connect those. So out of curiosity, how many of you have had a chance to play with the interactive network visualization? Oh, that's great. That's great. We'll play this. This is the green is going to be hard to see, but pretty quickly we're going to bring in other topics like Tai Chi. Okay, so us network guys, we like to have these networks that float around with these sort of forces. And this is available on the web that you can play with it, and it's also available outside. And I'm going to encourage you to try it out when you take a break. So this is what one portion of what my company does. We use technology to build tools that allow us to visualize data. And when we visualize data, we sometimes do that. I think data visualization happens in for one of two different reasons. One is to try and find some discovery in the data, so exploring it. But then once you've found something, you also have to be able to communicate it. I think those are two very different reasons for data visualization. And I think part of Elaine's real vision in what she's done with Osher is recognizing that there is a lot of power when you can communicate to the group what's going on behind the data, which in this case are all publications and co-authorship in institutions. As the CEO of a company that makes a large portion of our revenue from data visualization, I'm going to tell you a secret that you can't tell anybody, which is I don't really care about data visualization. What I care about is I care about innovation and how we can use technology to facilitate innovation. I care about human creativity. And I happen to think that data visualization is a very interesting way to facilitate innovation. But for me, what I'm very excited about really in the technology, in our growing understanding of networks, is innovation. And when I look at this network, that's what gets me excited, is that this is a large group of people that are all doing cutting-edge work in different areas. How can we use our technology? How can we use our understandings of the math and the dynamics that Dr. Barabazi talked about? How can we use that to connect the people in ways that make them more innovative? Let me show you another example of a network visualization that we we put together to kind of illustrate this from a different perspective. Wrong one. This is a different sort of visualization. This is another dot, but this dot represents a study about patients with MS done with Beth Israel Deaconess Medical Center. The diameter of that circle represents 413 patients with MS whose samples, kind of blood samples and DNA samples, were taken from a common biobank repository. The green represents another study, so that's SUNY Upstate Medical University. They took from the same biobank. What that means is just at random, if you have these two kind of uncoordinated studies, but they're pulling from the same biobank, in the middle, there is that overlap of red and green. Those are two different studies. They weren't overtly organized, but there's 140 people with MS that have been studied from both organizations in two different dimensions. And now we can see the overlap of 3 studies. There's a small 4th study. We can bring in 5 studies. When this starts to get overwhelming, we can turn off the connectors and we can just look at the stacks of overlap. And the Accelerated Cure Project has really facilitated this by having a simple rule that says we'll give you physical material for studying MS. You just give us the data after you do your study. And then they came to us and they said, well, we have all these data now from all of these different organizations. We know that they've probably looked at the same patients and that there's a lot of power in that. How do we communicate that? How do we show that? And we came up with this tool. And this tool is also about connecting dots. If you use this tool to look at particular organizations that we've selected over on the left, sure enough, just due to the scale, some of the things that Dr. Barabazi was talking about, you will find that there are a small portion of patients that have been studied by Beth Israel Medical Center, Glycomines, Pfizer, SUNY University Wellcome Trust. It's quite possible that, and there are cases where there's 10 studies, 12 studies, those study stacks are areas where we know more about those people with MS than anybody else with MS in the world. Now, why is that important to me, going back to the idea that it's not just about connecting the dots, it's about connecting the people? Why, anyone have any idea why I picked these 5 for this slide? These 5 organizations? What's that? Exactly. It's not what they have in common, it's how different they are. Right? There's academic, there's a medical center, small for-profit institution, huge pharma, university, trust. It's totally different. These are 5 organizations that would not necessarily collaborate together. They wouldn't think about writing a grant together. But yet, due to some infrastructure that's been created, they kind of already have collaborated together. They don't know it yet because they haven't seen this overlap, right? And what if we could then click a button on this study stack, and this is what we're working on next, click a button, send an email to those principal investigators, and tell them, hey, you've all studied the same 140 people from 5 different angles. Maybe you should compare notes and see if there's something new to be had there. What if we could make a real physical collaboration out of what started as a serendipitous virtual collaboration? To me, that's the real exciting thing about the technology, the kind of network technology that's evolving. Let me show you another example of networks. I'm going to show you a little bit behind the scenes of how we build our visualizations at Exaptive. So we developed this environment that is an environment in which we can bring in different kind of Lego blocks over here on the left, Lego blocks of code. See if I can figure out how to, oh, that was the wrong button. Oh, maybe this is the right button. There we go. So we bring in a Lego block of code. This is a text box. This is a PubMed data object. So we're bringing in a data source. This is a word cloud. Oh, that's the PubMed. This is a word cloud. And we are going to build up an interface over here on the right. And as we bring in our different components, that's a progress indicator, we're going to wire them together. So this is called data flow programming. And we wire them together, and what that does is it produces an application here that allows us to search PubMed and get back in a word cloud of results. So what I think is interesting about this is that this is another example of a network, right? Let's look at this. This is a computer program, but this computer program is made up of a few discrete different libraries. There's a data library, there's a UI library. We could make this more complicated. We could bring in natural language processing, algorithmic libraries. The point I want to make is that just like in the other networks I've shown, there's people behind the points, behind the nodes. Every one of these libraries was written by somebody. Every one of those libraries is used by a particular person. And what if we could unlock that sort of network? So one of the things we built into our platform at Exaptive was exactly this idea that by capturing the metadata, the network of the way people use programming libraries, we could create something that we call a cognitive network. So when somebody adds a component for connecting to a Transmart database, for example, we can build a network that says, oh, that frequently gets used by Magali Haas, and she looks at it using parallel coordinates. And that technique is also used by Eric Newman. And then this becomes a hypergraph. We can go out. We can say, well, what else is Eric Newman using? He's using an overlap diagram. Both of those were made by Stephen Ara. He's also using a bunch of different data sources. So the point I'm trying to get at here is that we have data and we have metadata, the data about data. And by harnessing the metadata that lets us get one step further out, meaning getting from the use case to the people involved, I think we open up a really exciting new potential for using technology to connect people together, not based on what they say, but based on what they do and how they're doing it. So we call this the cognitive network, and this is an example of a much more complicated computer program. This network builds this user interface over here. What's interesting is as we start building far more complex data analysis consoles in our Exaptive platform, we start seeing ScaleFree network dynamics over in our data flow environment, and we also begin to see ScaleFree network dynamics in the cognitive network of the sorts of components that are frequently used. This is why I think this is exceptionally important, because there's another type of network that we have to talk about, and I think that is ideas. It is increasingly gaining acceptance that ideas are a network. And this was something that was published in the New York Times just a few months ago called The End of Genius. We like the mythology of the lone genius that has a great idea in a sudden flash of insight. But it's not true. It makes a great story, but it's actually not how insight happens. Insight happens much in the way that Dr. Barabazi was talking about the sudden coherence of a network made up of a lot of individual parts. Somebody who's working on an idea hears different bits and pieces, and the ones that seem the most relevant begin to combine together, and at some point there is a critical mass, and that is the aha moment. But it's very much not the lone inventor's aha moment. It is the network's aha moment, and the lone inventor becomes the conduit to explain it once it's happened to him. And what's exciting to me when I think about that is I then look at these sorts of networks, thinking about the people behind them, and I don't see a network of multiple sclerosis studies. I see a network of ideas that have happened, those studies, and I see a network of potential ideas that have not yet happened. When I look at our programming environment, I see a network of ideas an idea that has been implemented, and I see a network of ideas that have not yet been realized. And when I look at this kind of wonderfully complex integrative medicine community, I see a network of ideas and a network of unrealized ideas. And what we're trying to do with our company, and what I'm very passionate about, is how do you realize those unrealized ideas? And just like Dr. Barabazi was saying, well, the first step in being able to to fix things, to be able to fix the communication problem in the company, is understanding how it works, understanding how networks work. Then you can start to make some suggestions about policy. I think if what we want to do is unlock new ideas, we have to kind of understand how they work. And I'm going to propose that an interesting word to understand how ideas work is this word exaptation. I've become so obsessed with this word, I named my company after it, even though it's hard to pronounce and everybody stumbles over it for a little while. I'm curious, anybody know the word exaptation? Yeah, I've already told him. Okay, so in the early 80s, Stephen Jay Gould, evolutionary biologist, published a paper. He called it Exaptation, the Need for a New Word in Science. He said, we're all excited about evolution and adaptation, but if you look at enough evolutionary processes, you see something that happens that's not just adaptation. It's something different. We don't have a word for it, and we need one. It's when something that evolves due to one set of constraints gets serendipitously co-opted for something completely different and ends up thriving there. It turns out that feathers evolved because they kept animals warm, and then they got serendipitously co-opted for flight because if you trap enough air to stay warm, you might flutter off a cliff and not die when a predator chases you off it. And I think that this isn't just a biological phenomenon. I think this is a cognitive phenomenon, that a lot of the aha moments are mental exaptations when we realize something that we thought only applied in one particular area can, often with that kind of flash of insight, we realize, oh, because of the network of ideas we've surrounded ourselves in, we now see that it can apply in some completely different areas. And I'm not just making this up. This happens all the time, right? So Gutenberg, most people know that Gutenberg invented the printing press. Not everybody knows that he went to a vineyard before he did so. If you actually look at the two mechanical devices, a wine press and a printing press, they're amazingly similar because one inspired the other. If we take a modern day example, this is by Jonathan Cachet, who's a neuroscientist postdoc. This is your zebrafish. This is your zebrafish on drugs. If you are trying to make a machine algorithm that figures out what drug your zebrafish took based on how erratically it's swimming, it turns out that you can exact a machine algorithm from the weather that looks at the way that a hurricane moves and figures out something about the storm based on its movement. Here's an example close to home. Do any of you guys know about the Astronomical medical project at Harvard? Okay. It's an astronomer and a neurologist met at a cocktail party. The astronomer, it sounds like a joke, it's true. The neurologist said, "What's hard about astronomy?" The astronomer said, "We're trying to infer a 3D reality from a bunch of 2D radio telescope images." And the neurologist said, "Oh, wow, that's like an MRI. It was really hard to read MRIs from a bunch of 2D slices until we got computer software that stitched it all together into a 3D model." And the astronomer said, "You have software that stitches it all together into a 3D model?" And so they plugged the radio telescope imagery into the MRI software, and they built 3D models, and they published a bunch of papers. So this at one level is extremely exciting, but I actually think it's also kind of tragic. I think it's tragic because this relied on two smart people meeting at a cocktail party and having a conversation in which they were able to talk at a high enough level of abstraction that they understood each other, and that's extremely rare. So my point is that when we're trying to facilitate innovation, I think serendipity is highly overrated. I love it, and it's romantic, and it's great, but can't we use technology to stack the odds in our favor of innovation and insight? And civil engineers have created a machine that manufactures serendipity. You guys know what it is? You gotta give me 1 extra minute on my talk because I'm soliciting audience participation. It's cities. Cities manufacture serendipity because they produce something that Jane Jacobs called productive friction. We get a bunch of us all in close proximity, and we have to wait in line for our mocha latte and maybe If we aren't completely caffeine deprived, we'll have a conversation with the other person that's waiting for their mocha latte, and we'll find out that that person in Cambridge is highly overeducated and has something interesting to tell us about our own project. That's how cities work. And software engineers build something different. They build social networks. And I was very excited when I watched the rise of social networks, because I said social networks are kind of like virtual cities. You can get 500 million to 1 billion people all packed into a little fiber optic cable. That's a city, the population density of which doesn't exist on Earth. That's going to produce lots and lots of ideas. But it doesn't, actually. It kind of produces a lot of cat videos and a lot of advertising. And what I realized is that, and I think that this, I would say, I think this is something we need to become more nuanced in the way we talk about it. Whenever we bring people together in these networks, we tend to call them social networks. But I would say that social networks are not the same as work networks, that people do not listen to hunky surfer Jensen Taylor on Google+ for the same reason that they listen to Steve Jobs. And that actually we don't need more social networks. What we need are cognitive networks. And this goes back to something that Elaine has talked about and Dr. Barabazi talked about, which is communities versus networks. Jane Jacobs said the definition of a city is everybody is a stranger. That's very different. That's very different than small towns where everybody knows your name and knows your business. And we need cognitive, in that way, Facebook and Twitter, these are not virtual cities, as I first thought. I think they're actually a lot more like virtual suburbs. What we need to create is we need to create a virtual city where people can come in and they can think hard about difficult problems and they can get tired, and then they can go back to their virtual suburbs and tweet and share pictures about their day. So we need cognitive networks that stack the odds in our favor of these exaptations that might lead to insight. And so I'll end by kind of leaving the ball in your court along those lines, which is we've created this network map. And in a few minutes, after you hear some interesting ideas, you're going to get to go for a coffee break. And I encourage you to use this map and find maybe not somebody that's one hop out from you. You already know that person. And maybe not even the person that's 2 hops out who's the hub, because everybody knows the hubs, but go another hop out. Find the person that you might not normally talk to at this conference and have a conversation that perhaps might lead to some sort of exaptation. I think that is what we have to do as people, and as a technologist, I feel like that's where we have to push the technology. And I think that what Helene has put together today is just an amazing step towards trying to do that together, because today you all are the people in the dots. So I hope you'll make the most of it. Thank you very much.